Today I'm going to go through question 8 of a mock paper, and this was to do with graph transformations, and particularly the graph transformations of some trigonometric functions. So, I want to know what sine of 2x and tan of x over 2 looks like for this interval of 0, 360. So I first of all want to know what just sine x looks like and what just tan x looks like. Well, sine x will do one full rotation, one full period between 0 and 360, and tan x, well, it's going to have an asymptote at 90. It's going to come through. It's going to have another one here. That is what they would both look like between these periods. So I need to know, what does this 2x do to the graph, and what does this x over 2 do? Well, the first thing I'm going to note is that for sine of 2x, that means there's going to be twice as many periods in that 0 to 360 range. So sine of x has one full rotation, one period. Sine of 2x is going to have two full periods. So it's going to go up and down and cut through at 180, and then it's also going to do the same thing again to 360. So this would be my sine of 2x, and it's going to have twice as many rotations because that 2 is going to shrink it in. The tan of x to the half, well, again, this is dilation, but instead of having now twice as many, because it's to the half, I'm going to have half as many. So here I had an asymptote at 90. That's going to now give me an asymptote at 180, because it's going to be stretched out. And it still starts down here. So therefore, what I'm going to get is it's going to... Oh, wait, no, it starts at the top, sorry. So I'm going to get across here, and it's going to start teetering upwards. And then likewise, it's going to start at the bottom, but this time it's not actually going to get across. It's just going to reach here. So these would be my two graphs, and this would be the graph of tan to the x over 2. Hence state how many solutions exist to the equation sine of 2x equals tan x to the half for the interval between 0 and 360, and state a reason for your answer. So, to find out how many solutions there's going to be, that's just how many times they cross. Well, I'm including 0 and 360, so I know they cross at this point here at 0, and I know they cross at this point 360, but how many other times do they cross in the graph? Well, there's an intersection point here, and an intersection point here, so for this question, there are going to be 4 solutions, because there is 4 points of intersection. 4 solutions as 4 points of intersection. And that would be all 6 marks for this question. So, thank you for watching. I hope you enjoyed. If you have any questions, please let me know, and I'll see you in the next one.